Hello 108 students, Mr. McHugh back here with you for section 5.1, working with exponents and our shortcuts. We're going to tackle page 2 of our class notes here, and we're going to jump right down to objective 3, and we're going to talk about the quotient rule. What do you do if you divide by the same base, if the variable is the same base, what can you do with the exponents? Now, imagine if I told you you were required to go the long way. And I said every student must take x to the 5th and write it out, expanded notation 1, 2, 3, 4, 5, x to the 3rd, 1, 2, 3. Don't forget, this means division. Fraction bars are division. And I said you must write these out and show all work. You guys would have a rebellion on my train here, or mutiny. And because then you would do all that, and you'd say, Mr. McHugh, anything divided by itself always equals 1, and you would turn around here and you'd cross all these out. And you'd say, how many x's do you have left? X times x. There's the result, x to the squared. Okay, long way. What's the shortcut? Look at the pattern. Look at the 5, look at the 3, look at the exponents. What did I do to get to the 2? I, class, did what? Subtract. So, here's what you say in English in your brain and burn it in. When you divide by the same base, subtract the exponents. Keep the base and subtract the exponents. Okay, I encourage you to get these English translations in you with algebra. You look in the book and you study these, and they give you Lawyery's rules, and they're in the purple highlights there, and page 267. You know, summarize these on your class notes. Okay, put them in words that you use. Hey, if you like the Lawyery's writing, go for it. But tell yourself whenever you divide by the same base, subtract the exponent. Okay, so here we go. Look at example 5. I wrote a couple of them out of the book. X to the 6th divided by x squared. Answer, x to the 4th. How did I get that? What's the intermediate step? Subtract the exponent. 6 minus 2 is 4. Okay, so we're cruising. Let's look at C. Divide by same base, subtract the exponent. 7 minus 12, x to the negative 5th. Oh yeah, we don't care for negative exponents, so what do? Write the reciprocal and change it to a positive. Okay, now, nothing wrong with that approach. Some of you might feel comfortable looking at x to the 7th divided by x to the 12th and say 7 minus 12 is a negative 5, and realize as soon as you see that negative subtraction, you can take a jump and take a super shortcut and go right down to putting the base with a positive exponent down in the denominator. Okay, some of you might feel comfortable with that. Alright, now what happens with something like this? Same base, subtract the exponents. Negative 2 minus 5 is a negative 7. Make sure you watch your signs when you do that. Don't care for a negative exponent, so drop it down, write the reciprocal with a positive, and that's what you get. Now, on my math lab, I don't have my calculator. You need to take 8, multiply it out 7 times to get the final answer, whatever that number is. Okay, I'm going to illustrate the concepts here for you. Now, what do you think about this guy? Here's something. Z to the negative 5 minus 8. Watch your signs. Negative 5 subtract negative 8. Turns out to be z to the 3rd. What's a negative 5? Turn it into what? Subtraction to positive. 8 goes from negative to positive. Negative 8 plus 3. Oh my god. Negative 8 plus 8 is a positive 3. Okay. There we go. We got that one cruising here. Now let's go look at objective 4. This objective 4 is called the power rule. There's variations on it. This one is a very powerful one. I'm going to give you a little shortcut I think will help you and just make it one big power rule. They've got rules A, B, and C here. You can check them out. Oh, you might want to be looking on page, sorry, I don't know. Page 269's got the summary of them. Power rules, yes, look on page 268. And they've got power rules A, B, and C. Okay, I'm going to summarize these things here for you. So here's the idea. Power rules is what happens if you've got a set of parentheses, you got a base variable, you got an exponent inside the parentheses, and you got one outside the parentheses. So I'm going to call this the inside exponent. I'll just put an I for that one. This one's the outside. Sometimes I call this the super exponent, just to distinguish it, but these are my terms. You're not going to hear these in a book, but if you come up with these concepts of an inside exponent and an outside exponent. Okay, if you don't know the rule, you'd be required to take x to the second. I thought I wrote this up, but it looks like I didn't, so I'll write it here. You would take x to the second and multiply it by itself how many times? The outside exponent says 3, so you go like this. And now you'd have to ask yourself, when I multiply by the same base, what do I do with the exponents? Hopefully you said add. 2 plus 2 plus 2 is 6. Now that's the long way to get the answer. Now let's review that. Long way. Take the basic definition of exponent. Take the base, which is x to the squared, inside the parentheses. Multiply it how many times? 3. So there you go. When you multiply by the same base, add the exponents, there's the answer. Now, here's the super shortcut way. Look at the 2, look at the 3, look at the final result. What did I do to them? Hopefully you see the multiplication. So whenever you have a parentheses, that I always think of parentheses because it's like kind of like the distributive property. Parentheses, you multiply. So you're going to multiply the inside and the outside exponent. You're going to multiply them. 2 times 3, boom, answer 6. Okay, so say that in your word. If you say multiply inside, outside exponents, these power rules basically are variations of that. Now look at this example B here. Here's the trick I like to teach in class. Instead of writing this out 3 times, you see the outside exponent is a 3, question mark, do you see inside exponents? Well, there is nothing listed, so what do we assume it to be, class? Hopefully you're popping up the ones. I like to pop them up, write them in there, because now what triggers in your head? When you multiply inside exponents, outside exponents, do what? Multiply. 3 times 1, 3. 3 times 1, 3. There's your answer. Done. Okay, let's take one a little more easier to see. Inside exponents, outside exponents, different variables. Multiply them. 2 times 4, 8. 3 times 4, 12. And there's your answer. Okay, not too bad, huh? Let's look at example C here. Oh, what do we got? Now, this would tell you to take x over y, multiply by x over y. How many times? 2 times. X times x, x squared, y times y, y squared. Now, a shortcut to do this and is to, again, follow back onto, do you have inside exponents? The answer is yes. A 1 and a 1. If you don't see an exponent, it's assumed to be a 1. Now, you have an inside exponent, outside exponents, multiply them. 1 times 2, x squared. 2 times 1, doesn't matter which way you say it, y squared. And you're on your way. Okay. So far, so good, hopefully. Let's look at a couple 6a. What do you think this one would be? Inside, outside exponent, multiply them, 24. Okay, pretty easy. How about this guy? Pop up the ones. 3 to the 4th, you take a 1 times 4, 1 times 4, 3 to the 4th, y to the 4th, your final answer, 81, y to the 4th. Remember, it's 3 times 3 times 3 times 3 to get 81. Okay, a couple more here. If I see a number, pop up the 1. 1 times 2 is 6 squared. 7 times 2 is 14. 6 squared is 36, and you're done. So these are kind of fun. Once you know the shortcuts and you've got them verbalized in your head, you can do this all night long, all day long. Okay, so pop up exponents when you need it. Okay, here we go. -2 raised to the 3rd. Show the work. M, 5 times 3 is 15. Z would be what? 1 times 3 is 3. Do we care for negative exponents? Excuse me, not negative exponents. That's a negative base. -2 times itself 3 times is a -8. So let's watch that. And you're done. Okay, Mr. McHugh, we are wrapping up page 2, and we still got a lot of work to do. So when I see you on the next video, I'll be on page 3 with you. Okay, take care. Bye.